Hello, ladies and gentlemen, and today we're going to start our notes for Unit 4, Notes 5. So this time we're factoring when A is not equal to 1. Yesterday we did when A is equal to 1. Now we're learning what we're going to do when A is not equal to 1. So before we get going, I want you guys to try 1 and 2. Make sure you remember how to do factoring by grouping. Remember to set up your two groups, and then you want to factor Y out of the first group just to give you a head start. Okay, you want to make sure your leftovers match so you can factor them out. So what do we do when we're factoring when A is equal to 1? Well, remember that general form of a quadratic is ax squared plus bx plus c. Okay, so when that leading coefficient, or that A, is not equal to 1, we have a different way of factoring than when it is. So it's important to remember which way is which before you start factoring, so you make sure you use the correct method. So really check yourself. Is A equal to 1 or is A not equal to 1? That's something you need to make sure before you move on. So here are the steps that we're going to do. First of all, you should always check to see if you can pull out a greatest common factor. A lot of times by checking out to make sure you can take out a greatest common factor, you can actually make an easier problem to factor for yourself. The next thing you want to do is determine the value of A after you've taken out the GCF. Is it 1? Is it not 1? Sometimes you take out a factor, a greatest common factor, and then A is 1. So you can go back to what we did yesterday. But if you take it out and A is not 1, then you have to go through this method that we're learning today. So step number 3 is setting up that X. Okay, so remember, we're multiplying A times C, putting it in the top as a product, then we're putting B in the bottom, and that is our sum. So next thing you want to do is solve for that X. So what factors multiply to the top and add to the bottom? Next thing you need to do is rewrite the equation by splitting up the B terms. So then lastly, you want to factor by grouping. Splitting up the B terms might not make sense to you right now. Hopefully it will in a minute. The point of what we're working towards is getting 4 terms so that we can use the factoring by grouping method. In order to get 4 terms, we have to use the X. So let's take a look at what this will look like. First of all, we need to look and see if there's a GCF. So if we check through number 3, 7, 29, and 4. Can't take out a number and I can't take out an X. So I'm going to set up the X because I'm going to have to factor it using the A equals not is not equal to 1 method. So I'm going to multiply 7 times 4 and I get 28. And that's going to add to 29. Okay. Now, I want to look at factors of 28 that add to 29. So I have these factors here, and I want to see which ones add to 29. They're all positive. 1 plus 28 is actually 29, so I can write those in my X. Now, yesterday you would go through and you would just write out those factors and be done. Well, today you can't necessarily do that. Okay, because our A is not equal to 1, we have a different method. So what you actually have to do now is I'm going to take this equation and I'm going to rewrite it. So I'm going to make it 7x squared plus 1x plus 28x. Sorry, I'll make that a little more clear for you. 28x plus 4. So if you look, it's really the same equation. 1x plus 28x is equal to 29x. But by splitting it up, I now have 4 terms, so I can use that factoring by grouping method. So from this first group, I can only take out an x. When I divide out an x from each term, I'm left with 7x plus 1. From this second group, I can take out a 4. When I divide a 4 by each term, I'm left with 7x plus 1. Last but not least, check, do my leftovers match? Yes, they do. So then I'm left with 7x plus 1, and then I write what's left over when I factor those out, which is x plus 4. So if you were really confused, you think I went through that really fast, if you don't remember how to factor by grouping, please go back and watch video number 2. Okay, because at this point, I'm assuming you can factor by grouping, and I'm assuming you know how to factor out a greatest common factor. So if those two things are still difficult for you, please go ahead and rewatch videos 1 and 2. I'm going to go ahead and have you skip number 4 completely. It's kind of an icky problem, more so than I had intended. So let's take a look at number 5. So we want to find things that multiply to 45 times 3, which is 135, and add to 24. Well, this is not necessarily very straightforward. We can't look at this and be like, bam, I already know what that is. So let's just kind of play around with the number 135. Well, we know 1 and 135 is factor. 2 won't be a factor because it doesn't work. Maybe 3 is a factor. Let's try. Take 135 divided by 3 and you get 3 and 45. Well, that doesn't add to 24. Okay, both of them are going to be positive. So I take, let's see, 135 divided by 4. That's not a whole number. 135 divided by 5 gives me 27. So then I have 5 and 27. Then let's try 6. Oh, 6 doesn't work. 7. 7 doesn't work. 8. All I'm doing, guys, is I'm just going through and trying things out till I find factors. So I'm just going up from 1, dividing 135 by different numbers because I don't just automatically know what things multiply to 135. So the next thing I found was 9 and 15. Well, let's think about it. 9 plus 15 is 24. So what you guys want to do is just play around with your calculators a little bit. So it's going to be really important this unit that you're bringing those to class, okay? So 9 and 15 are my factors. Okay. So then what I can do is I can write these out and then I'm going to factor by grouping. So I'm keeping my A term the same. Now I'm taking this 24x and I'm writing it as 9x plus 15x. Notice I'm still putting x's with each thing. When I split it up, they still both have an x. 9 plus 15 is still equal to 24. This is still the same equation. I just made it so I have 4 terms. Since I have 4 terms, I can go ahead and factor by grouping. So out of this first group, I can take out a 3 and an x, and I'm left with x plus 3. Out of this second group, I can take out a 15, and I'm left with x plus 3. So, do my leftovers match? X plus 3, x plus 3. Yes, they do. So I can factor those out, and then my second group is 3x plus 15. So once I have my 2 factors, I'm done. Okay. Next, let's take a look at number 6. So number 6, let's set up our x. We can't take out a greatest common factor between 2, 5, and negative 2. Well, 2 times a negative 2 is negative 4, and a positive sum of 5. Well, we know we need to have a minus sign and a plus sign. That's the only way we can get a negative product. So for negative 4, things that multiply negative 4, negative 1, 4. Positive 1, negative 4. 2, negative 2. Let's see, negative 1, 4, 1, negative 4, 2, negative 2. None of those are going to work for me. So remember, when none of them work out, that means that our answer is not factorable. And that will happen from time to time, both on the A equals 1 and the A doesn't equal 1. Okay? So sometimes it doesn't work out. Not very often, but occasionally it will. When that is the case, I do want you guys to make sure that you put not factorable somewhere. Please don't just leave it blank, because leaving it blank tells me you're not done with the problem, that you didn't finish your homework. So let's take a look at number 7. So for number 7, we want to multiply 5 times 6 is 30, and we want to add to 13. So we want to think of factors at 30 that add to 13. Well, we have 1 and 30, 2, 15, 3, 10. Well, when I make out those lists, I already see something that's going to multiply the B, 30, and add to 13, and that's 3 and 10. Everything's positive in this case. So now I'm going to take and I'm going to split up that middle term. So I have 5x squared plus 3x plus 10x plus 6. So I took that middle term, I split it up as 3x and 10x. So now I'm going to go ahead and make my groups. Okay, out of that first group, I can only take out an x, and then I'm left with 5x plus 3. Out of the second group, I can only take out a 2. When I take that out, I'm left with 5x plus 3. Then notice that my leftovers match. So because they match, I can factor out a 5x plus 3. And then I'm going to write what's left over, which is x plus 2. Okay. All right, let's take a look at number 8. So for number 8, we have 4 times 7, which is 28, a positive 28, adding to a negative 1. So that means both our signs are negative. So factors of 28, we have 1, 28, 2, 14, 4, 7. All of those need to be positive. There's no way I can take all of those positive numbers and get a negative 1. So again, we have one of those cases that is not factorable. You can't just assume, however, that because you can't think of anything right off the bat that it's not factorable. If you think that it might not be factorable, I want you to go ahead and write out some of the factor lists just to make sure. Okay, don't just assume. Last thing I want you to do is go ahead and try 9 and 10 on your own. Okay, so I want you to try 9 and 10 on your own and see if you can come up with factors that work. Some of them might be not factorable, some of them might be. Once you're done, please go ahead and take that quiz.